Hello, everybody. My name is Randall Dupree, and my company is called Forge Point LLC. And today I'm going to talk to you all about lean. And the content of today's conversation is really based on my book, Everyday Lean, which is available on Amazon and Barnes and Nobles. But really, it's all about taking a very quick, high level overview of lean and continuous improvement and introducing you all to some basic concepts and tools that would help you to identify value and waste within your processes. So let's get into it. A little bit about me. So I've led lean and continuous improvement transformations for over 20 years. And I've worked for several different companies, including Boeing, Goodrich, Train, GKN. I am a Six Sigma black belt and a certified lean practitioner. I am also a Maxwell certified leadership team member, speaker, trainer, coach, and I'm the author of a few books. One, which is the basis of this talk today, called Everyday Lean. So that's a little bit about me. Now I want to give you all an overview of continuous improvement and really what it's all about. So under continuous improvement, if you picture it as an umbrella, there are several different systems, lots of different tools. And so I'm going to give you a little bit of an overview today of a few of them. So, under the continuous improvement umbrella, you have things like Kaizen, Six Sigma, Lean, theory of constraints. And these are all different systems of eliminating waste. And depending on the problem you're trying to solve or the improvements you're trying to implement, you may use several of these, or you might use one of these, but there's definitely some overlap between the different systems. But at the core of continuous improvement, it's all about making small incremental improvements over time. And it's all about going to the Gemba. The Gemba is simply the place where the work is happening. So if we're talking about a manufacturing process, the Gemba would be the shop floor. If we are talking about a law firm or an accounting firm, the Gemba might be the office space or it might be the courtroom. If we're talking about a hospital, it could be the ER or the OR. Really, it's any place that the work is happening. And at the end of the day, continuous improvement, regardless of the system that we're using, it's all about trying to improve safety, quality, and flow. And we do that by removing waste. So another term you might hear, and it's very synonymous with continuous improvement, is Kaizen. Kaizen literally translate from the Japanese into good change. A good change that is ultimately converted into continuous improvement. So a lot of people see continuous improvement and Kaizen as one and the same. The slight difference, I would say, that Kaizen is a little bit more focused on employee empowerment and leadership is definitely a piece of that. Whereas some companies and organizations that focus strictly on continuous improvement might not involve the empathetic leadership as much or the collaborative approach to leadership as much as the folks who focus more on Kaizen do. But that's a deep dive for another day. One important thing to recognize is that most of what we know about Kaizen or most of the tools and the techniques come from the Toyota production system, which was founded by Taishi Ono. Taishi Ono is known as the father of lean, and one of his famous quotes is that where there is no standard, there is no Kaizen. In other words, everything starts with having a standard and it ends with having a standard as well, because part of the continuous improvement cycle starts with having a standard, improving that standard, and then creating a new standard based on the improvements. So, with that, let's go ahead and dig into some of these other systems under the continuous improvement umbrella, starting with lean itself, which is all about the relentless elimination of waste. So, in a minute, I'm going to define waste and I'm going to define value. But just know that lean is all about getting rid of the waste. And when we talk about waste, we don't mean trash or rubbish or leftover materials necessarily from different processes. What we're talking about is the waste that shows up in any and every process that's common across any industry. And I'll get into what we mean by that here shortly. Just know that at the end of the day, what we're trying to do by removing waste is we're trying to improve flow from the process from the start to the end throughout the entire value stream. We're going to use various different tools to do that, different techniques, but really what it starts with is learning to see the waste. one of the tools that we use to see the waste is a value stream map, which essentially is just a visual illustration of a value stream. So if you think about a value stream as starting with the customer and ending with the customer, maybe it starts with a customer order and ends with a customer delivery. All of the steps involved, whether they add value or not, would be part of that value stream. And within that value stream, some of those steps are going to add value, some of them are going to be waste. And so lean is all about trying to minimize or reduce or eliminate as much of that waste as possible. Six Sigma, on the other hand, in my opinion, is more of a quality tool. And the reason why I say that is Six Sigma is all about reducing variation and improving a process's capability. That's measured in something called CPK. And the way that shows up is you see the three targets on the right side of the screen here. The first target shows a process that really is not capable at all. It's a process that is really it's not repeatable. We don't really know what the outcome is going to be every time we work this process, and if we do happen to hit our customer specifications, it's usually only by accident. As we move from the top left to the top right target, we're seeing a process that's becoming more repeatable. It's becoming more capable, but we're still not quite able to meet our customer expectations. Our shots are a little bit more grouped, they're a little bit tighter in a grouping, but they're still not quite hitting the center. Then below, what we see is another example of a process that is actually a capable process, a process that is has a tight grouping, so we know it's repeatable. We're getting the outcomes that we expect to get, but not only are we getting expected outcomes, but we're also getting outcomes that are meeting our customers' expectations. So Six Sigma is all about collecting data and following the DMAIC process to ultimately end with a controlled process that is predictable, it's repeatable, it's reliable, it hits our customer expectations, and it is also removing as much variation from the process as possible. The DMAIC process that we follow to do this is it stands for define, measure, analyze, improve, and control. In each one of those phases, there are certain tools that we use to go through that phase and to work the project and eventually make our process more repeatable. A term to be familiar with here, and we'll cover terms again at the end, is DPMO, which just stands for defects per million opportunities, which is ultimately how we measure a process in terms of its level of sigma. So a Six Sigma level project just means, I'm sorry, process just means that for every million opportunities, we are only seeing 3.4 defects. So think about that. Every million opportunities will only create 3.4 or less defects, and that would be a Six Sigma level process. For a process to be Five Sigma, on the other hand, that means for every million opportunities, we're going to see 233 defects. And then for Four Sigma, we're talking a lot more. So it raises all the way to 6,000 plus defects for a process to be Four Sigma. And depending on your industry and what the process is, there are cases where only Four Sigma or Five Sigma might be required because there's a cost associated with making a process more and more capable and removing more and more variation. So in the healthcare industry and aerospace, Six Sigma is probably going to be more of the norm, right? We want to make sure that there's as little opportunity for a defect as possible when we have people's lives on the line. Well, when we're making a widget like a phone, for example, or maybe a box of cereal, things like that, there's probably less of a need for the process to be Six Sigma level capable because we're talking about um, a lot lower chance of hurting people or causing deaths and fatalities and things like that. So, depending on the amount of investment, will determine the amount of sigma level that we want to drive to, and it usually ultimately has to do with the impact it's going to have on customers. Theory of constraints. Theory of constraints is all about finding and exploiting the bottlenecks. Similar to the Six Sigma process, we have steps that we follow. In this case, it's not DMAIC. In this case, what we do is we start by identifying where the bottleneck is, then we exploit it, we subordinate it, we elevate it, and then we repeat. And we repeat because as we exploit one bottleneck and eliminate one concern, we're going to create a new one. So Really, at the heart of theory of constraints is all about finding that limiter for the entire system, because every single process within a system is going to have a limiter. And sometimes we find that the easy way for us to exploit a bottleneck is simply by moving some of the work content from where there's a bottleneck to some of the areas where there are excess capacity. Sometimes we got to just increase the capacity of the bottleneck in order to improve the overall system. Um, Eli Goldrath is an expert in theory of constraints, and he is quoted as saying, "Any improvement made anywhere other than the bottleneck is an illusion." In other words, if we focus on a process that is not the constraint, that is not the bottleneck of the system, we're not going to improve the entire system. We have to focus on the limiter to improve the health of the overall system. So, theory of constraints is basically giving us the tools and the framework by which we do that. Okay, so now let's talk about value and waste. So, value added activities from the customer's perspective has to meet three criteria. And when I say customer, we could be talking about an internal customer who is part of a downstream process, or we could be talking about a final customer, someone who is actually purchasing a product or a service. Now, from that customer's perspective, in order for something to be considered value added, it has to meet three criteria. And those criteria are: it has to transform the product or service, thing, fit, form, or function. It has to be completed correctly the first time. So no rework, no defects. And the customer has to be willing to pay for it. They have to see enough value in the activity that they're willing to pay for it. If we can answer yes to all three of these questions, then the activity, the step, the process that we're looking at would be considered value added. If we can't answer yes to any one of these, then it's considered waste. And it's important to understand that there is a difference between value added activities and important activities, because there are all sorts of important activities that has to be done that technically are not adding any value, either because they are not changing the fit, form, and function of their product or service, or they're not things that the customer is willing to pay for. So when you think about some of those activities, there are things we got to do just to operate a business. Things like paying our taxes, right? Things like hiring and firing and performance conversations. Sometimes there's quality checks and inspections or engineering work that has to happen that then enable the value added activities, but are not in and of themselves adding value. So when we think about things that are not adding value, we really have two different categories. We have non-value added activities, and then we have non-value added but necessary. So NVA and in NVA. And what I always tell people is, if you think something is necessary, that doesn't mean we just leave it alone. We still look for ways to either automate it or reduce it, or minimize it, or maybe we just challenge it, because sometimes things we think are necessary turns out that they're not necessary. That maybe there's requirements that are no longer valid, or maybe we put together some sort of countermeasure that was just a band aid till we fix something and it just kind of stayed in place, and that happens quite a bit. So there are two different types of waste. There's the necessary and the unnecessary non-value added activities. The things that are not necessary, that we identify as not something we actually have to do to run our business, those are the waste that we usually want to focus on. Those are the low-hanging fruit. And so those are what we are going to dig into next, because they show up in every process. Whether you're baking a cake or building an F-15, these eight wastes are going to show up. And these wastes are defects, overproduction, waiting, non utilized talent, transportation, inventory, motion, and excess extra processing. Now, we remember these eight wastes with the acronym downtime, because these wastes often do lead to downtime. And it's important to note that these wastes are connected. For example, if there are defects, well, there might be a lot of extra processing that's going to need to happen to correct the defect. If we have lots of transportation, which is moving parts or components around an office space or a factory, there's probably going to be lots of motion, which is people movement, bending, twisting, turning, walking, crawling, reaching, right? There's going to probably be a lot of motion if there's transportation. If we're overproducing, there's probably going to be a lot of inventory that's building up. So all of these different wastes are connected, and it's very possible that one type of waste might lead to another. Ultimately, we want to eliminate these things where they show up. What I like to tell people, especially folks on the shop floor who are maybe mechanics or operators, is we're not trying to tell you how to turn your wrench faster. We're trying to eliminate the things that prevent you from turning the wrench in the first place. So if you're waiting for parts, it's not about turning a wrench faster. It's about getting you your parts that you need and when you need it. If you're having to walk around a lot to find tools or dies or fixtures, we want to eliminate all that motion and bring you what you need at the time that you need it. If you're having to personally deliver something that you've just produced, whether it's a form that you printed off and signed or a software program that you've developed, if you have to physically transport that to another department or another team or another site, those are things that are just adding waste that we want to eliminate so that you can focus on the value added work. Once we identify the waste that are in our processes, there are plenty of lean tools out there that help us to eliminate them. I've already touched on the first one you see here, which is the value stream or the value stream map. We want to map out all the steps in the process and identify which are wasteful and which are value added. And then what we want to do is we want to look for ways to eliminate that waste and improve the overall process. Another important tool that I've alluded to earlier is standard work. As Taishi Ono mentioned earlier, we want to start and we want to end with the standard. Where there is no standard, there is no improvement, right? So we start with having standards in place, and every improvement we do, we create a new standard because we want that improvement to be sustained. And the way we do that is with standard work. A3s are for problem solving. So at the end of the day, A3 is just a paper size, but it is a tool that we use to start by very specifically defining a problem, identifying the root cause, possible solutions, and then ultimately implementing solutions to solve problems in a way that they won't come back. There are plenty of lean tools out there. This is not an exhaustive list, but it's a list to get you started as you're looking for ways to eliminate waste. Some common terms just to be familiar with. A3, I've already touched on it. It's just a paper size. 5S, this is a really good tool that can be implemented in really any type of environment. 5S stands for sort, set in order, shine, standardize, and sustained. Sorting is really all about taking a look at what you have and removing the things that you don't have, throwing out the trash. If there are things that you don't need, you get rid of it. If there's things that you use, but you use it very, very infrequently, we may store it a little further away from the Gemba. Then we set things in order. So we identify a home for everything. And we want to make sure that there is a place for everything and everything is in its place. Then we shine, we clean the space. So once we've already gotten rid of the rubbish and we've put everything else in its place, we want to clean and we want to make everything presentable. Then we standardize. So we need to put together a process here to ensure that we don't go back to the way things were before. We have very clear standards. It's very obvious what needs to be done, where things go, and anyone who's working in that area knows exactly what they should be doing. And then sustaining. Sustaining is all about just creating accountability and some sort of method of ensuring that we are following those standards and maintaining the improvement that we've seen. DMAIC we've touched on. That is something we use in Six Sigma. So is DPMO. PDCA. PDCA is really the process by which we go about implementing any sort of lean improvement. We plan it, we do it, we check it, and then we act. And it's just a cycle that we repeat. We plan, we do, we check, and we act. And when we act, we're basically going to act based on the check. So if we check and we see that what we are doing works, then maybe the act is we sustain what we're doing. If we check and we see that it doesn't work or there's more improvement that's needed, then that will lead us to more activities. A pick chart is visualized here on the screen, and it is a way for us to prioritize improvement activities. So if you do a lean event or a Kaizen event, such as a value stream map, then are going to list out all of the different waste that you're going to see, and you're going to come up with ideas to eliminate that waste. Some of those ideas may be quicker and easier to implement. Some may be harder and more of a challenge and take more time and resources to implement. Some of those improvement ideas might have a small benefit or a small impact, and some might have a much larger or greater impact. A pick tool essentially helps us to organize these different improvement ideas based on how much effort they're going to take and how much of an impact they're going to have. Some other terms to be familiar with are takt time, which is basically a calculation of our available time and our customer demand. It tells us how fast or slow we should be producing. Cycle time, it is the time it takes for a single process or activity to be completed. And then lead time is from customer to customer. So the time it takes for all of the activities within a value stream to be completed, starting with our customer order and ending with a delivery to a customer. Here are some questions to think about. So, hopefully, you've gotten some tools today to help you improve your processes, whether it is a business process or a manufacturing process or some sort of service that you own. The first question to think about is, what are the processes that you own? What are in your scope of authority that you actually have control over to improve? What are some examples of value added steps within those processes? What are some of the necessary non value added steps within those processes? And ultimately, what are the wastes that you see? Contemplating these questions will give you some areas that you could start to focus in on. At the end of the day, learning to see the waste and identify that it's there is really half the battle. Once we could see the waste and we know what we need to remove, then we could start to prioritize the improvements and make the changes that are going to benefit everybody and ultimately improve our processes. So, hopefully, this has been helpful and you've learned a little bit about lean and continuous improvement today. Again, my name is Randall Dupree. My company is called ForgePoint LLC. And if you go to forgepointllc.net, I'd be happy to connect with you. You're able to book a free discovery call with me, and we could take a look at your processes and your organization and determine what sort of challenges you're facing and what sort of tools we would need to use to help you improve. So, again, my name is Randall Dupree, and I hope this has been value added for you. Thank you for your time.